More statistical functions. We're going to talk about statistical functions, beginning with the large and small function, which gives you the first, second, third, ninth, largest or smallest number in an array of numbers. The rank function, which gives you the ranking a given number has in an array of numbers. The percentile function, which will tell you what value is greater than X percent of an array of numbers. The percent rank will tell you what percentage of an array of numbers that a given number is greater than. The forecast function will forecast a y for a given x when you have known x's and y's. And the frequency function allows you to count the data points that fall within certain ranges called bins. So statistical functions, the large and small functions, both which have the same arguments, an array and something called k. The data that I have on the worksheet is some financial data for some industry groups for the stocks that are traded on the NASDAQ stock exchange. And we're going to focus on the after-tax operating margin, which is in column Q. So the first thing I want to do is sort my data by the content in column Q by going to the Data tab and then sort in descending order so that I have my largest values at the top. Because we're going to begin with the large function, LARG, tabbing that into the cell, first selecting my data array, and I can select the entire column, and then inputting the k value, which if we make k1 will return the highest value, 2 will return the second highest value, 3 the third, and so on. So I'm going to select the third highest value, Control Enter, and then formatting that so it matches the data a little bit better, the percentage with 2 decimal places. The third highest value is 24.62. The small function works exactly the same way in the opposite direction. Selecting the data array, selecting the second smallest value, Control Enter, and then reformatting that. It's negative 15.91%. And these functions don't have to have the data sorted in any particular order for them to work, because I'm going to first resort by ascending order so that we can see that the second highest value is 15.91%, and then I'm going to resort again alphabetically by the industry name. So the rank function. There are actually 2 rank functions that do slightly different things with the ranking, which we're going to see in a second. So first we're going to look at the rank average function by putting a rank average function in a cell. Tabbing that into the cell. The number I want to rank is 100, and I want to rank that number in reference to all of the numbers in that group, in that column, comma, and the optional argument is ascending or descending. I'm going to first select ascending, tabbing that into the cell, and then I'm going to go back and make my range reference an absolute reference. And 100 in ascending order is last. Copying this down, 65 is first, 80 is second, and with the average rank function, when there is a tie, like there is in the third and fourth position, the average function takes the values in position 3 and 4, which are tied. 3 plus 4 is 7, divided by 2, which is 3.5, and assigns that ranking to 3 and 4. And then continues with the rank assignments. 100 being the fifth value, the highest value, which would be fifth if you're ranking in ascending order. Descending, as you might guess, works exactly the same way. I'm going to rank 100 as part of this group of numbers. I'm going to rank them in descending order. Control Enter. Make the group of numbers an absolute reference, and then copy that down. And now, in descending order, the pair of 90s is in the second and third position. 2 and 3 equal 5, divided by 2 is 2.5. And then the rank picks up the order again, with 80 being the fourth lowest number and 65 being the lowest number, and assigning those numbers respectively 4 and 5. The rank EQ handles ties a little bit differently. Tabbing that into the cell, I'm going to reference the number, the group of numbers I want to rank that number within, and the order is going to be ascending, which is 1, going back to make the range absolute, closing the parentheses, Control Enter, and then Control C and copying that down. This rank function handles ties by assigning the same number to all numbers that tie. So in ascending order, 65 comes first, 80 is second, then we have 90 and 90 in the third and fourth position. Both of them get assigned 3, and then rank picks up the ranking by assigning 5 to the number 100. And in descending order, it's the same thing, only in reverse. We select the number, select the range of numbers, make that an absolute reference, go to the optional argument, descending. That's first, copying that down. Second place gets assigned to the numbers that are tied in second and third place. The fourth place picks up 4, and the fifth place picks up 5. Percentile EXE, or exclusive, and percentile inclusive, INC, are percentile functions. They won't generate the same number, which we'll see in a second. The percentile INC will generate the same number as the old percentile function, both of which will return a number that's wrong. And I have it on here sort of as a warning, because I'm going to show you that it returns the wrong number. And in order to do that, we're going to manually figure out what the right number is. So the percentile function should return the value for which a given percentage of the numbers in an array are lower than. So how do we do this? There's a formula in cell B13 that we're going to use to manually calculate what value 90% of these numbers that are in this range are lower than. So how do we go about doing this? We have 14 records. 14 equals n in the formula in B13. So I'm going to set up that formula, 14 plus 1 times the percentage, which is 90.9, equals 13.5. So I know that I want the value that's between 13 and 14. In fact, it's the value that's right in the middle. The problem is we really don't have a value that's between 13 and 14, so we're going to have to impute a value. And the way we're going to do that, first I want to pull the value that is in 13, which is 56, and then the value that's in 14, which is 90, into those cells. And then I'm going to take the difference between those two numbers, which is 34. If there was a record 13.5, it would be, as far as this calculation goes, midway between the two values, 90 and 56. If the total difference is 34, well then half of that difference must be half of that, which is 17. And to get that value, the last thing we need to do is add the value that is the 13th record plus the midpoint between the 13th and the 14th record, which is 73. So if the percentile function gives us the correct number, it should give us 73. Well, let's see if it does. Tabbing that into the cell, the array are the scores, test scores. Some of them are pretty bad. And the K number is 90, which is 0.9. And the result is 73. But watch what happens when we use the other percentile function. And you might notice that there's 3 of them. I mentioned this at the opening of this segment for the percentile function, is that percentile INC inclusive is equal to the old percentile function. So we're going to do both of them. We're going to tab that into the cell, select the data array, comma 0.9, and it's 55.7, nowhere near 73. And the old percentile function that has a little warning next to it, you can see that little yellow square with the exclamation point, and it has that warning because it's as wrong as the percentile INC function. In fact, it's exactly as wrong. So the moral of the story is use the percentile exc function. The percent rank function is similar to the percentile function in that there's a current version that you should actually use, which is the exc version. The inc version equals the old percent rank function, which you'll find on the list of functions, along with the percent rank function that was the old version. Neither of which you should use. You should use the current one, the exc. It is true, however, that the larger the data set, the less of a difference it makes whether you use the newer version or the older version. So I've got my data again, which is some financial data that's summarized for the industries that are traded on the NASDAQ stock exchange. And we're going to use it to set up a percent rank for the data points. I'm going to put the percent rank function, exc, and there's all three of them listed right there, but that's the one I want. First, define the array. I'm going to select the entire column for that. And then select the value, the data point that I want the percent rank for. And finally, there's an optional argument that allows you to define the number of decimal places you want the result returned in. I'm going to select 2, Control Enter, and the result tells me that 7.44% is greater than 35% of the data points. I'm going to double click and copy that down and then resort the data by the after-tax operating margin in descending order so that we get a clear idea of what's going on, and I'm going to reformat those cells. So the percent rank returns a value, a percentage, for which the selected data point is greater than the percentage of numbers in the data array that's shown by the percent rank function. So 35.58 is greater than 98% of the values in the data array. 33.84 is greater than 97% of them. And I almost have 100, not quite, in this data array. But that's why we're basically going down 1% each subsequent data point. But what's nice is you don't have to have your data sorted in any given order for the percent rank function to return the correct percent ranking. The forecast function. The forecast function will return a y for a given x for known y's and x's. The limitation is that the forecast function assumes a linear relationship between the independent variables, or the x variables, and the dependent variables, or the y variables. And to show how this works, I've got two progressions, a linear progression and an exponential progression. The linear progression adds 3 to each previous value. So I first start with 1 and add 3 and get 4, add 3 and get 7, then 10, 13, and so on. So my 11th value should be 31. Let's see how the forecast function does. Equal forecast. The 11th data point, my known y's are right there, my known x's are right there, entering forecasts that my 11th data point value will be 31. That's exactly right. The second progression is exponential. I've multiplied the first value 1 by 2, and then that value by 2 again to get 4, and then by 2 again to get 8, 16, 32, and so on. So, but for the fact that the forecast function is a linear function, it would otherwise return a value for the 11th data point of 1,024. But what does it actually do? Equal forecast. The 11th data point, the known y's are here, the known x's are here, entering, I get approximately 342, and that value is the value that's the 11th data point after you draw a straight line through all of the prior data points, 1 through 10, and fit that line such that the differences between that line and all the other data points net to 0. So the forecast function imposes a linear trend when there is a linear trend, which is what you would want, and when there isn't a linear trend, which may not be what you want. And finally, the frequency function that has two arguments, the data array and the bins array. We've got our data that we've used a couple of times already in this movie, which is some financial data, some summary financial data on the industries that are traded in the NASDAQ stock exchange. And we're going to find the frequency of the payout ratio, which is the percentage of net income that a company pays out to its shareholders in the form of dividends. But to get there, I need to find out a couple things, or I want to find out a couple things about the data that's in that array. The first thing I want to find out is how many data points do I have. I'm going to use the count function that'll return the number of values that are in a given data array, because I know the frequency function deals with values and not text. So I'm going to enter and control home to go back up. So I have 89 data points. I also want to find out what the largest data point is. So I'm going to use the max function and select the range again, control home. And then the min function, tabbing that into the cell, selecting the data array again, control home. So my maximum value is almost 81% and my minimum value is almost 0. What I want to find out is how many data points fall within certain ranges of values called bins. So we're going to set up some of those bins. The first one being between 90 and 80%, the second one being between 80 and 70%, the third one between 70 and 60, and so on, going down to 0. So I've established my bin, and the range of the high and low is greater than the maximum and minimum value of my data points. That will become my bin array. And now I'm ready to put my frequency function in these cells, because I wanted to find the number of data points that fall within each one of those bins. Equal FRE, frequency. I'm going to first define my data array. I can select the whole column N to do that. And then define my bins array, which is right there. Control Enter. And I get a total number of data points of 89, which equals the count function, which gave me the total number of data points that were numbers. So that ties out, and I'm going to right arrow off that so we can see that. And if I go back and sort my data by the payout ratio from highest to lowest, I can see that in fact I have one value that's between 80 and 90%, which is right there. I have one value that's between 70 and 80%, which is right there. I have four values that are between 60 and 70%, which is right there, and so on. So the frequency function allows you to add up the data points that fall within the range of values established by your bins. So that was the last of the statistical functions, starting with a large and small function, which gives you the first, second, third, ninth, x largest or smallest data point in an array. The rank function, which returns a ranking that a given number has within a larger set of numbers. The percentile function, which gives you the value for which that number in an array of numbers is greater than the given percentage of numbers that you define. The percent rank function will tell you where a given data point ranks in terms of percentage in an array of numbers. The forecast function will forecast a y for a known x, given known x's and y's. And the frequency function will tally up how many data points fall within certain ranges of values called bins.